to find the partial fraction decomposition of x plus 1 over x squared plus 5 plus 6. Right, the first thing to zero in on is the fact that this quadratic denominator x squared plus 5x plus 6 will factorise quite nicely into x plus 2, x plus 3. So I'm going to write x plus 1 over x plus 2, x plus 3, right? So the form of the partial fractions will be of this form. So it'll be 2 something over x plus 2 plus something else over x plus 3. And this sign is an identity sign, which means it works for every value of x. So it doesn't say is equal to, it says is identical to. This is not an equation, it's an identity, right? So we need to find values of a and b that make these two exactly identical. So what you can do, you can look at this partial fraction sum on this side and you can kind of find a way of adding these. So you're probably going to use this kind of approach with a common denominator of x plus 2, x plus 3. So x plus 1 over x plus 2, x plus 3 is identical to, so that would be ax plus 3 plus bx plus 2 over x plus 3 x plus 2. So at that point you're going to you can multiply through by the denominator x plus 3 x plus 2 x plus 2 x plus 3. If you multiply through by that, it will just leave you with x plus 1 is identical to a x plus 3 plus b x plus 2. So you want to expand these brackets, so ax plus 3a So you've got two methods of approaching this. One of them is very quick and often efficient depending on the form of the partial fraction. Another one is incredibly useful over other areas of the HL Maths course. I'm going to compare coefficients first. So what we're going to do is expand these brackets. So it's going to be ax plus 3a plus bx plus 2b, so x plus 1 on the left hand side. So then what you can do, you can group the x terms together and the constant terms. So x plus 1 is identical to, so the ax, you've got ax plus bx. Well, if you factorize that, that is a plus bx, that's how many x's you've got, plus, and the constant term is 3a plus 2b. I don't really need a bracket around there, but I'm going to put it just for effect. Right, so now you can compare coefficients. What I mean by that is you've got to have, these two are completely identical expressions, so the number of x's on the left hand side must be equal to the number of x's on the right hand side. The constant term on the left hand side must be equal to the constant term on the left hand side. So if we compare coefficients of x, so on the left hand side we've got 1x, so 1 equals, on the right hand side we've got a plus b. If you do the same for of the constant term, well, the constant term is also 1, so 1 equals 3a plus 2b. So what you can do, I've just rewritten these two equations, so you've now got two nice linear simultaneous equations from which you can find a and b. You're probably going to multiply this one by 2 or by 3 or times it by 3. So that would say 3a plus 3b equals 3. I'm just going to write this one underneath it. So 3a plus 2b equals 1. You're going to subtract. So that is going to say b equals 2. And then, well, if a plus b equals 1, so a plus 2 equals 1, so a must equal 1 minus 2. A equals minus 1, which means that x plus 1 over x squared plus 5x plus 6 is identical to minus 1 over x plus 2 plus 2 over x plus 3. I'm not going to do it here, but you could check that by adding these together and check that they equal exactly the same thing. Right, the alternative approach would have been, and it would be a lot quicker, when we were at this stage. You may remember we were at this stage a bit earlier, so we had x plus 1 is identical to ax plus 3 plus bx plus 2. That was just after we'd multiplied through by the denominator x plus 2, x plus 3. So because this works for every value of x, this means for every x, so it works for all x, what you can do, you can substitute in useful values of x. So useful as in because they eliminate one of these letters, so you can find the other one. So basically, if x equaled minus 2, well, that's going to be quite handy to get rid of b. So you're going to have minus 2 plus 1 is identical to, so a minus 2 plus 3 plus b, well, minus 2 plus 2 is just 0. So that is telling me that minus 1 is identical to minus 2 is just a. So a equals minus 1 as it did before. And you can, to find b, well, you could use your newfound a, or you could just substitute minus 3 in. So I'm going to do that. If x equals minus 3, so minus 3 plus 1 is identical to, so a minus 3 plus b minus 3 plus 2. So that is minus 2, 0, a minus b equals minus b. So that is telling us that b must equal, so if minus b is minus 2, b must equal 2, as it did before. Right, this method is handy and it's quick, but as we'll see later, when certain forms of partial fraction, when you've got repeated factors, if you sort of substitute one number, it'll wipe out all of your unknowns, so it won't work. But it's really, really handy for this.